Hi, we're going to take a look at arithmetic sequences, and we're going to start off with this somewhat intimidating formula. It's intimidating because it has a whole bunch of letters in it, and people would prefer numbers. But by the end of this video, we're going to feel very comfortable using that thing. We won't even be intimidated. In fact, I'm sure you have some experience with arithmetic sequences. We just may not have used the same vocabulary in the past. So I look at this example right here, and this is an arithmetic sequence. And you can tell right away as you look at that there's a pattern that you can follow. We'll talk about that pattern in a little bit, but we're going to call this the first term in the sequence, and it would get this symbolism called A sub 1, A subscript 1, A sub 1, or the first term in the sequence. A sub 2, the second term. A sub 3, the third term. So you get it. Somewhere way over here, way over here off the page is probably an A sub 78, the 78th term in the sequence. You also notice as you're looking at this that there's a common difference. I go from 5 to 9 by adding 4. 9 to 13, 13 to 17. I keep adding 4. So in this case, there's a common difference of plus 4. Now, side note, if you have a sequence and the common difference does not exist, meaning you don't keep going up by 4 or down by 2, then that would not be an arithmetic sequence. Any sequence that wants to be proudly called an arithmetic sequence must have a consistent common difference, or it's not a common difference. Okay, so we're going to continue working with this same sequence, and now we're going to start looking at that formula. The formula you see up there, we're going to put it into action. So I've recopied the formula. There it is. And we're going to start to take a look. This A sub n, that's going to stay. That's just the general term that says we're doing a arithmetic sequence. The A stands for the arithmetic sequence of n number of terms, because this thing could go on forever. But to do this, we need A sub 1. That's your very first term. So there's your A sub 1. We labeled it A sub 1 earlier. A sub 1 plus D, that's going to be your common difference. My common difference in this case is plus 4 times n minus 1. So I'll just literally take the number that represented the first term, the number that represented the common difference, and now I have my formula. So the second piece that I circled, that's your arithmetic sequence formula for this sequence that we're looking at right there. The one that you see below that, we're just putting a little different symbolism on it, since we're used to now working with function notation. And what I mean by that is you're now comfortable with, if we had y equals 2x plus 7, turning that into f of x equals 2x plus 7. We realize that they're the same thing. So likewise, I can write my sequence this way, or I can write it in function notation this way. Same thing. All right, so now let's see how we could use this arithmetic sequence. As I look through this thing, I've gone to 1, 2, 3, 4, 5, 6, 7 terms, but what if I wanted to go to the 21st term? I'd have to keep following this pattern out to the 21st term, and you don't have time for that sort of thing, do you? Heck no. So if I want to find the 21st term, I can use either one of these formulas, and I show them both below. If I'm going to use this formula, that means I want the 21st term, A sub 21. And then that just means my n is going to be 21, so I put a 21 right there. Everything in that formula remains the same, except I put in a 21 where I used to see an n. I can solve it, and this tells me that if I were to go out to the 21st term, that would be 85. If you don't want to use that form and you want to use this form, it's the exact same thing. F of n, f of the 21st term. So if I'm going to plug in a 21 there, I need a 21 there. And miraculously, I get the exact same result. If I go back up to the top and I say, well, this is the 4th term. Let's see if my formula works for that. It sure does. Check this out. I plug in a 4. And I get out a 17. Just what I figured I should get using that formula. Okay, that's the basics of how to use the arithmetic formula. And I'm going to just point out a couple of spots in your notes that you should take a deeper look at. You have access to these notes. They're on the lesson plans, a link to a blank set of the notes if you already don't have a copy. And what I have for you right here is a filled out version. And if you were to take a look through here, by watching the first part of the video, you would see a lot of things that you're familiar with. You should be able to look at these vocabulary terms and say, yeah, I know what that means. This next section, it shows you an example of a sequence that's not arithmetic because the common difference is not there. It's not common. We have a 2, 3, 4, and a 5, whereas in an arithmetic sequence, the common difference is always the same number. This section shows you how to build your sequence given the first term and the common difference, but you should be already familiar with that. And if you want more practice, down here are 2 more examples of building your formula and using your formula to find different values. These 2 would be good practice for you to make sure you can build from those, build that formula, because look how clunky that sequence looks. There's a chance that you would get disrupted there just because the numbers are clunky. I'm continuing to hit the highlights on these notes, and I've turned over to the back side. If you look at this sequence on the back side, I have a common difference of -4. I'm going a reduction of 4 to each new term. And as you go through this part in the notes, you would see that if you were to take these terms and plot them, for example, the second term is a -6. That gives me a second term is a -6. I can plot that as an ordered pair. At 2, my value is -6. In this case, my third term is a -10. So I can plot a 3, -10. The point is, if you start graphing these, you will get this set of discrete data. But if I think about the slope between these, and I do my rise over run or my y minus y over x minus x, I get a slope result of -4, which is the same as the common difference, which tells you slope and common difference are going to yield the same result. And finishing out, just hitting the highlights of these notes, you would notice example number 4, that you have quite a tough one. So this would be a good one to take a closer look at to see what a tougher question in this arena would look like. The 5th example, what we're doing here is we're just going to the function notation that we talked about at the beginning of the video. That just replaces the symbolism. So there's no difference in the concept. Okay, that is your tutorial introduction on arithmetic sequence and the arithmetic formula. Know how to derive it, and then know how to use it to find different terms. See ya.